students, welcome back. This is Torres, elbow bump. How are you? Are you doing okay? Is your family okay? Remember, if you need anything, please send me an email so that I can try to help in some way. So lucky you get to hear my voice for another lecture. But the best part is we will be putting everything we've learned together and work with the 4 steps of hypothesis testing. Yay! So as I said, we're going to put everything that we've learned so far together. And we're going to actually start going through the whole process of hypothesis testing and break it down into 4 clear steps. Now at this point in our course, the problems that we're going to be doing are going to take a while to complete, and they're going to involve all kinds of components that we've worked with thus far. So let's go over each step individually and then we'll do an example. So the first step of hypothesis testing is writing your hypotheses. So you're going to state your null and your alternate hypotheses in terms of the population parameter. So you're going to either use P if it's a proportion or mu if it's a mean. The second part is you're going to choose your significance level. So you're going to choose your alpha ahead of time. And you're also going to find the test statistic, in this case the ZCrit, that matches your significance level. You're also going to check any requirements that you may have. So for example, you're going to check for normality. And if you cannot check for normality, then you're going to check for the conditions of the central limit theorem and make a decision on whether you have enough evidence that your data is normally distributed before you can proceed. In the compute to compare step, you're going to compute your test statistic, so in this case, your Z obtained, and find the p-value for your Z obtained. You will compare the p-value of your Z obtained to the significance level, or your alpha, that you selected in the prepare phase, and you will also compare your Z obtained to your ZCrit. Finally, you're going to look at that comparison and decide if there is enough evidence to make a decision on whether you should reject or retain, in other words, fail to reject your null hypothesis. And you should state the conclusion in context of the study. So it just goes in a very systematic way. So at the end of the 4 steps, you can decide if you're going to reject the null or retain the null. Okay, so we're going to do an example about tigers. This is the example. Each year, 5% of the world tiger population is killed by poachers. Now that there is a campaign to educate people on the problem, has the percent gone down? 300 tigers were observed and 18 were killed by poachers. Okay, so let's go ahead and take this over to Ziteboard and we can do all our work there. Okay, here I've gone ahead and posted the information that we need on Ziteboard. I've posted 2 things. First, I've posted the hypothesis steps at the top: hypothesize, prepare, compute to compare, and interpret. And then I've also cut-pasted the problem that we're going to be working with. Okay, so let's do each one of these in a different color. Let's start with green. We'll do hypothesize in green. So here's our scenario. Each year, 5% of the world tiger population is killed by poachers. Now that there is a campaign to educate people on the problem, has the percent gone down? We need a null and an alternate. So our null is going to be P, because we're working with a proportion, right? This is a percent, equals 0.05, because that's what we expect to have. Now we need our alternate. The alternate addresses the question. So HA, has the number gone down, or has the percent gone down? So we're looking for a decrease of 0.05, and we get that from this part right here. In the next step, we're going to do all the preparing. So we're going to go ahead and do this one in red. Okay, so let's choose a significance level. Well, I'm just going to go ahead and choose an alpha of 0.01. And I'm going to tell you why. I would probably use a 5% alpha, but because this is 5%, I don't want you to get confused in the example. So I'm just going to go ahead and keep the alpha different. I'm going to say this is a 1% alpha or 1% significance level, and I am risking committing a type 1 error once out of every 100 trials. Okay? I also need the ZCrit that matches this alpha. Now, I see over here that this is just a one-tailed test. I'm only concerned with things that are less than 5%. So this is less than 5%. This is a left one-tailed test. Okay, so it's a left one-tailed test. So I need the significance level for a left one-tailed test. And that information is in this document. I will also link this down below for you. And here I have my different kinds of hypothesis tests. Here I have the two-tailed test. I don't need that one. Here's my left one-tailed test, and I need it for 1% alpha. So this is the one that I'm going to use. I'm going to use negative 2.326. So my ZCrit is going to be negative 2.326. Very good. And I also should write down what my N is. So my N is 300. And let's go ahead and figure out what my P hat is. P hat is 18 out of 300. And if I bring over my Google calculator and clear this out, I have 18 divided by 300, and I get 0.06. Okay, so let's see where we're at right now by drawing my normal curve. So I'm going to go ahead and just draw it over here to save a little bit of space. Here is my normal curve. I'm going to go ahead and write my Z-scores right here. And the estimated population mean is 0.05. I'm going to make this a little bit bigger so that I can make it easier for me to write on this. So this is going to be, right here in the middle is going to be 0.05. And I need to know this distance right here. So this distance right here is not available in the problem. We do not have the standard deviation for the population. Before I go much further and do too much calculation, let's just double check that we have some evidence that this is normally distributed. So in order for us to do that, we need to apply the central limit theorem, because there's nothing in here that says assume that this is normally distributed. So the first is random and independent. We don't have a lot of information about this, except I can only say that tigers running around in the wild, that's the only place they can be killed by poachers. I mean, poachers can't get them at the zoo. That's not really poaching. So I would say that we're just going to assume that this is met because tigers wander around randomly. Number 2, we need to see if there is the condition of a large sample size. And we need the number of successes to be greater than 10 and the number of failures to be greater than 10. So here we have 300 as our sample size, and we have 0.05 as our estimated population proportion. So let's bring over Google Calculator. Clear, clear, clear. 300 times 0.05 equals 15. and 15 is greater than 10, so that checks. So if these are my successes, my failures have to be everything else. So my failures are going to be 285, and 285 is greater than 10, so that checks out. The last one is the large population. In this case, we have to know that our population size is at least 10 times the size of the sample. So n has to be at least 10 times the size of the sample. So as long as n is greater than 10 times 300 and n is greater than 3,000, we're good to go. Now, I don't know what the tiger population is right now, but let's just assume that's also met, and we can assume the distribution is normal. So now that we can assume that the distribution is normal, I'm going to go ahead and zoom into this. We need to figure out what this distance is. And since we don't have the population standard deviation, we're going to have to work with the standard error formula for the proportions. And if I remember correctly, the standard error formula is SE equals radical P times 1 minus P divided by N. So let's plug everything in. So P is the population proportion, 0.05, times 1 minus 0.05, divided by our sample size, which is 300. And if I bring over my Google calculator, just put it right here, I've got, clear, I've got 0.05 times parenthesis 1 minus 0.05 close parenthesis equals, and I'm going to divide that by 300 equals, and then I'm going to take the square root of that number and get 0.012. So my standard error for this is 0.012. And I'm just going to go ahead and just say it's 0.1. So I'm just going to go ahead and zoom this in again and assume that this area right here, or this distance right here, is 0.01. So down here, what would match is 0.06, 0.07, 0.08, and in the opposite direction, I'd have 0.04, 0.03, 0.02. Okay, so let's match all this stuff up. Okay, I'm concerned to see if things have decreased from right here. Okay, and I have set an alpha level of 0.01 left one-tailed test. I am saying that this ZCrit is negative 2.326. So in order for me to reject, and I'm going to go ahead and put this in blue. In order for me to reject, I need to get a number, I need to get a Z obtained that is less than this, and I need to get a p-value that is less than this. So I'm looking for anything that would be in this area right here. This would be my area of rejection, and anything above that would be my area of retention. Okay, so at this point we've done all the prepare, and you can see how much time that prepare part took. Now we're finally, and I'll zoom this in, I hope this isn't making you sick. Now we're going to go ahead and compute our Z obtained and find the p-value for a Z obtained and compare it to our model right here. Okay, so I'm going to do the compute and compare. Let's go ahead and do it in this magenta or fuchsia color. What's the difference between fuchsia and magenta? I don't know which one that is. Okay, so I'm going to do compute and compare. So compute and compare has me calculate my Z obtained. So my Z obtained is going to be calculated using p hat minus p divided by SE. So my p hat, as we had up here, I'll scooch this down. My p hat that I had up here was 0.06. And my p I had from here that's 0.05. And my standard error I had from right here, and that would be 0.012. Okay, so now, same thing, got to bring my Google calculator out here and do some calculations. So let's see what I got. I got 0.06 minus 0.05 equals, and then I'm going to divide that by 0.012 equals. And I get a Z obtained of 0.83. Move this out of the way. And now I just need to figure out the p-value for 0.83. So I found this free calculator online. It doesn't work as nicely as StatCrunch, but it does work and it's free. So I thought I would try this one out instead with you today. So this is just the normal distribution calculator, and we're going to go ahead and put in the information that we have to see what the probability is of obtaining that result. And so I'm going to see if I can make this a little bit smaller. I want to make sure that we get a chance to see this one more time before I have to cover it up. Here I have that the number that's in the middle, right, with the 0 Z-score is 0.05. Our standard error is going to be 0.012. Okay, and we're looking for less than this. Okay. All right, so we have this information. Our Z obtained is 0.83. Okay, let's see if I can remember all this stuff. So we used P instead of mu, but the calculator doesn't know that we're working with proportions or means. So we can still put in proportion information here. So we're going to go ahead and put in 0.05 here. And the standard deviation is going to be our standard error. So our standard error for this situation was 0.012. Okay, and we are going to be concerned with p-values when x is less than, and this is asking for the p-hat, and our p-hat was 0.06. And let's go ahead and click where it says show me an explanation and hit compute. Okay, look at this. We said that we would reject anything that was down here. So we needed a p-value that was just going to be a little bit less than 2 standard deviations below the mean. But this is a whole lot more. This exceeds it. We said our alpha we would reject if we got a probability of less than 0.01. This is the probability that we got. So let's go over to our model and let's go ahead and put that in. And I'm going to go ahead and this is still the compare phase. So this is what we got right here. Zoom in on this guy. Okay. 0.06, we already knew where it was going to be. 0.06 was way out here. We said it had to be in the area of rejection for us to reject, but look where it is. It's in the area of retention. So we're going to go ahead and retain. So our Z obtained was 0.83, and the probability of Z obtained was 0.7967. This had to be less than 0.01, and it's not. It's more than 0.01. So these are the two things we're comparing here. We're comparing ZCrit to Z obtained, and we're saying that if it's less than our ZCrit of negative 2 point something, what did we say it was? Our ZCrit negative 2.326. and positive 0.83. We said if it's less than this number, then we will reject. It's not, so this is saying retain. We also said that our alpha gets compared to our p-value. Our alpha is 0.01, and we're going to compare it to 0.7967. We said that if our alpha is more than our p-value, we will reject. So in other words, that our p-value has to be less than our alpha, we will reject. It's not, so we're going to retain. So our decision is retain the null. The last step of the 4 steps of null hypothesis statistical testing is interpreting the information. And I'm going to go ahead and put that information in just black. Okay. So the interpret is going to be here. I'm going to go ahead and scroll down and see what this says. So I'm trying to make it all fit in one space. So we have decided that there is not sufficient evidence to reject the hypothesis of no difference. Okay, we're going to retain it. So the question was, each year, 5% of the world tiger population is killed by poachers. Now there is a campaign to educate on the problem. Has the percent gone down? So in context of the question, they wanted to know, is there less poaching? They put this money out to do this campaign, and they want to know, is there evidence of less poaching? And according to your sample, there is not sufficient evidence to conclude that the campaign has been effective or has had any effect. We cannot say that there is no proof. We can't say that it's proven that it doesn't work. We can only say there is insufficient evidence that this campaign has been successful in the decrease of poaching of tigers. So what do? We reviewed the scenario and we wrote down the null and alternate hypotheses. Next, we prepared. We chose the significance level and found the test statistic, in this case the ZCrit, that matched that alpha. We also checked the sampling distribution's conditions. In this case, we checked to see if it met the conditions of the central limit theorem for proportions. We also created a model, and we found the standard error for that model. Next, we used the standard error, the p-hat, and the p to compute the z obtained, and that's our test statistic. And then we used the calculator to compute the p-value for the z obtained. Finally, we looked at the p-values and the test statistics. When comparing the p-value to the alpha, if the p-value had been less than the alpha, we would have rejected the null, but it wasn't. Our p-value was greater than our alpha. So we retained, or another way to say that, we failed to reject the null. Finally, we stated the conclusion in the context of the study. So what's the big idea? Today's big idea is that there are 4 steps in hypothesis testing, and this provides a systematic process to answer the research question concerning the population parameter. The 4 steps are hypothesis, prepare, compute compare, and interpret. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new videos for this course. Okay? This is your teacher Torres saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video. Ciao!